Alright, so our first video is going to be a review of Algebra 1. And in this video, we're going to be solving equations. So guess what our objective for this lesson is? It is to solve algebraic equations. Alright, our objective in this lesson is to solve algebraic equations. This is the vocabulary for this lesson. Most of you all should be familiar with it, so pause the video here, read through the information or write it down. Make sure you understand what it means because I'll be using these terms later in the video. Alright, so this is our last two terms with this lesson. I do want you to pay particular attention to underneath the like terms there. I have examples and non-examples. So your examples are things that are like terms. Non-example, non is a prefix that means not. So a non-example is something that is not an example of, in this case, like terms. So pause the video, write this information down, and start it up when you're done. Alright, so we're going to start with, I'm going to show you some examples of how to solve a one-step equation. When we solve an equation, we're wanting to isolate the variable. That means get the variable by itself on one side of the equal sign. So I want to get rid of everything that's on the side of the equal sign with the variable. So my variable here is y. So I want to get y by itself. So I want to get rid of that plus 4. So I'm going to do that by subtracting 4 from each side. Now when I have 4 plus negative 4, or 4 minus 4, my 4's cancel out. So I am left with just the y on this side of the equal sign. Now negative 12 minus 4 is equal to, you're at negative 12 on the number line and you move 4 more in the negative direction. So that puts you at negative 16. So my solution for this equation is y equals negative 16. Alright, example 2. I am undoing subtraction, so I undo it with addition just like I did on the previous problem. I'm going to add 5. And so my variable here, w, is by itself and it's going to be equal to 29. Finally, number 3. Alright, I have negative 12b. When I have a number in front of a variable, the math operation between those two is multiplication. And to break up or undo multiplication, I have to do the opposite, which is division. So I have to divide by that negative 12. That gets rid of my coefficients there, and I end up with my variable b. And this division here gives me a positive 3. Alright, finally, my last example with the fourth step. I have x over negative 4. I am dividing there when it's written in that format, so I have to multiply each side by not just a 4, because this has a negative in front of it, it has to be a negative 4. This causes my 4's to cancel out, and I'm left with x, and over here, 7 times negative 4 is negative 28. And that's examples on one-step equations. And that took way. Alright, now we're moving on to two-step equations. So 2 steps means there's 2 math operations that I have to undo. So first of all, I have multiplication. 7m means I'm multiplying 7 times n, and then I am subtracting 17. So the first thing I have to do to solve this is I have to get rid of the 17. Think of it as your order of operations. When you solve an equation, you're working backwards. You're starting at the bottom and working your way up. And I am going to have to add 17 to each side to get rid of the subtraction. And then finally, I am going to undo my multiplication with division, and that gives me m equals 11. Alright, the next example is a 2-step equation. Why don't you pause the video and see if you can figure out it yourself, and start the video again when you're done to check your answer. Did you get it right? Check your answer with mine. If you didn't, go back and look at what I did and see if you can correct yourself. Alright, so here's two more two-step equations that we're going to solve. These are a little bit different, so I'm going to go ahead and walk you through how to solve number 3 and number 4. So first of all, in number 3, you'll notice that this p minus 15 is all divided by 9. Since that entire quantity is divided by 9, we can't get to the p minus 15 until we get rid of the division by 9. So to do that, we're going to multiply both sides by 9. And I'm going to multiply this side by 9. And what happens is my 9's cancel out. And I'm left with p minus 15 equals negative 54. Alright, now I have a one-step equation, and you all should be able to solve that one-step equation. You only have p minus 15, so you're subtracting 15, so you have to do the opposite, so you have to add 15 to each side, and that gives you p equals negative 39. Now for number 4, we have 2/3 n minus 6 equals negative 10. That 2/3 n is 2/3 times n. So we cannot break apart that multiplication until we get rid of our subtraction by doing the opposite. So we're adding 6 to both sides. So now we have 2/3 n equals negative 4. Alright, now you can there's a couple ways you can do this. First of all, I'm going to show you how you break it apart step by step. Let's see, I want to get rid of the 2/3, so I'm going to get rid of my division by 3 first. And then I have 2n equals negative 12, because negative 4 times positive 3 is a negative 12. And then I'm going to get rid of my multiplication with division. My 2's cancel out, and n equals negative 6. Alright, I want to show you another way, and it's a little bit of a quicker way, and this is what I normally do. Whenever you have a variable multiplied by the fraction, instead of breaking it apart in 2 steps like we just did, you can actually get rid of that entire fraction in 1 step by just multiplying by its reciprocal. If you multiply by its reciprocal, then it's going to cancel out and you're going to get 1n. Alright, now since I multiplied that side by 3/2, I have to multiply the other side by 3/2. And that gives me n equals top times top. Write it on the top. And then I have a 2 on the bottom, and that gives me n equals negative 6, which is the same answer, just a little bit less steps on that one. Alright, now we're moving to an example of an equation that has a variable on each side. So if you look, I have a 10y on one side and an 8y on the other. And remember, to solve an equation, I have to have the variable isolated on one side of the equal sign. So that means I have to have a y on one side. And what I usually do is I normally get rid of the smaller one. So I have a 10y and an 8y. So I'm going to get rid of my 8y, and I'm going to do this. This is a positive 8y, so I'm going to subtract 8y from each side. Once I do that, I get negative 2 plus 2y equals negative 1. So now I've got a regular 2-step equation, which we've already solved, so you should be able to do this on your own. So pause the video, try to solve it, and restart it when you have your answer. Alright, so I got my solution for y to be 1/2. Is that what you got? If not, pause the video, check your work with mine, and see if you can determine where you went wrong. Okay, here's another example with a variable on each side. I want you to try this one on your own. I would like to give you a hint before you start. You're going to have to use your distributive property and get rid of that number in front of the parentheses before you can do any solving. So pause the video, try to work it on your own, and then restart the video and check your work with mine when you're done. Okay, I got 8 for my answer. What'd you get? If you got something else, see if you can compare your work to mine and see where you went wrong. If not, you can't figure it out, we'll talk about it tomorrow in class. Alright, here's another one I want you to solve, and I want you to solve it on your own. So go through and try to solve this problem. Remember to get rid of the parentheses first, and you are going to have some like terms. Remember, like terms are terms that have the same variable with the same exponent. You're going to have to combine them and put them together. When you're done, restart the video and we'll compare answers. Alright, well, you've turned the video on and see if what happened to you, happened to me, happened to you if you got the same result. What I got was here, I got 5 on one side of the equal sign, and I have an equal sign here and it says negative 35. Well, obviously, 5 is not equal to negative 35. So, this is a type of problem that you may see if all of your variables cancel out and you're left with two numbers, one on each side of the equal sign. If they are different numbers, you get no solution. Your answer is no solution, or you can use the null set, which means no solution. Alright, so here's another problem that I want you to try on your own. Remember to use the distributive property and combine all your like terms. You've done all this in Algebra 1. So pause the video, try to solve it. When you complete the problem, turn it back on, so restart it so you can check your answer with mine. Alright, while you were solving this problem, you may have noticed something back here, at this step right here. You have 3k minus 2 on one side of the equal sign, 3k minus 2 on the other side of the equal sign. Your variables cancel out when you try to get them on one side, and you end up with negative 2 equals negative 2. Whenever you have exactly the same expression on each side of the equal sign, you get what is called an identity. And an identity means that any number you substitute in for that variable is going to be a solution. So what that means is your solution here is all real numbers. Anything you plug in will work, and this is actually the math symbol here for all real numbers. So your solution to this is any number you plug in, any real number you plug in. Alright, so here's our last problem, and this is a challenge problem, and I want you to do this on your own. You're going to use the same concepts you used to solve an equation. And when we just had one variable, it's just this time we have more than one, but we want to solve this equation for y. So I want to get this y by itself. So I'm going to use the same principles as I did before on all my other solving of the equations, and I'm going to get that y, isolate it, and get it by itself. So I need to get rid of that positive 3x, and I need to get rid of that multiplication of negative 4. How are you going to do that? So think about that, work this problem out. We'll see what you get tomorrow. Bye.